I think is not what you think. You're here and I am already here. Without further ado, in order to understand how machines understand human language, let's use a reading test as an example. There is only one sentence in the reading part, which is, "The weather is so refreshing today, and the wildflowers on the road are fragrant." Test part. Question 1 is, what is the weather like today? Question 2 is, what will happen to the wildflowers on the road if the weather is refreshing? Question 3 is, will the wildflowers smell fragrant tomorrow? Your answer must be hum hum ha ha ha, but the point is, how does the machine understand this article and then answer the 3 questions? Does it have to understand what the weather is, what refreshing is, what the mountains are, what wildflowers are, and what fragrance is? The attention mechanism that everyone talks about now relies on 3 weights: query, key, and value, which are actually the key to the machine understanding this article. But it is understood in the form of statistical analysis, or to be more precise, it is achieved by matrix operations of correlation coefficients. In fact, the machine does not know the meaning of these words at all. The only thing it knows is the correlation between these words during the training process. The so-called correlation, simply put, is when one word or word appears, another opportunity appears. In other words, the root of the knowledge the machine understands is the sum of the text we input. His understanding of each word is actually the correlation between this word and all other words in various fields. So he doesn't actually understand the meaning of any word, but this method can analyze the structure and correlation of any human language, even non-human language, and then answer questions and organize documents. Or translate. From a practical point of view, it is actually more practical than understanding. Back to the reading quiz. After the machine is trained, it begins to analyze our sentence. If the first word picked is today, and then based on this today, all the questions related to today are found, query. Then use the word today to compare it with all other words, such as weather, such as refreshing, such as fragrant, and find out the correlation between the two, query to key. At this time, based on the training it has received, it may find that weather is more relevant and fragrant is less relevant. These related words receive relatively high attention. The words that receive attention will find out the content, value, that answers the question. Today gives weather attention, and we continue to scan the next word, weather. Weather also gave refreshing attention. In this way, each word has an attentional relationship with other words. These relationships are the key to our analysis of all questions in the reading test. First question, how's the weather today? From the attention mechanism, we already know the strong relationship between today's attention to the weather and the weather to refreshing. We can easily find the answer, value, based on his previous training. Question 2. The weather has become refreshing. According to his past training and attention mechanism, refreshing will bring road in, road will bring wildflowers in, and wildflowers will bring fragrant in. The answer, value, is ready to come out. Question 3 asked, will the wildflowers be fragrant tomorrow? Tomorrow will awaken the attention of today, but because tomorrow is not today, I don't know whether the wildflowers are fragrant or not. Back to the title. I think, not what you think. You are here and I am already here, which means that the way the machine thinks is statistical analysis of text, not understanding of the real world. And this text must exist first before machine learning can exist.